Okay, so welcome back. Let's look at a few examples on the applications of differentiation to consumption functions, cost, and finding marginal cost and marginal revenues. So this example is number 60, right? It says that given the full revenue function, find the marginal revenue and the average revenue. So my revenue function is given by, okay, it's first of all says that given that the demand of a product. Okay, so we are not directly given the revenue function here. This example says that the demand of a product is given in terms of its price as 500 over Q, right? Find the marginal revenue and the average revenue for that product. Okay, so we are only given the demand in terms of the price. So we need to start by finding the revenue first before we can differentiate it to get the marginal revenue and divide by Q to get the average revenue. So we know revenue is price times quantity. So which in this case will be 500 over Q times Q, which is 500. All right. So therefore, our revenue is 500 and our marginal revenue, which will be dr dq, is going to be 0. All right. Since 500 is just a constant, and our average revenue, which is revenue over Q, will then be 500 over Q. So our average revenue is the same as the price. Okay, so that's that one. Let's take another example, the same type of example. Price here is given to be Q plus 750 over Q plus 50, and we are asked to find the marginal and the average revenue. Okay, so first things first, our revenue function, which is price times quantity. We've been given the price to be this, so we multiply it by quantity to get our revenue times Q, which will be Q squared plus 750 over Q plus 50. All right, 750Q. Q squared plus 750Q over Q plus 50. So this is our revenue function. So that marginal revenue will then be dr dq, derivative of revenue with respect to quantity. And clearly this function is a quotient function. All right, so we can only apply the quotient rule in differentiating it. Numerator is my u, denominator is my v. All right, so the rule says v u prime minus u v prime over v squared, which in this case will be, keep denominator the same, v, keep v constant, u prime is differentiate numerator, so we differentiate term by term. So this term by power rule gives us a 2q, okay, plus this term by constant product rule gives us 750, minus, keep u the same, so keep the entire numerator the same, right? Differentiate v. V is our denominator. We differentiate term by term. So differentiate Q, we get 1, plus differentiate 50, we get 0, since 50 is a constant, and divide everything by the square of the denominator. All right. And usually, as I said, you can usually always leave your answer like that. You don't necessarily need to simplify further. Okay, now sometimes they would say that you should find the marginal revenue when Q is equal to 5 units, for instance. All right, then at this stage, after getting your expression for the marginal revenue, you can then say at Q equals 5 units, our marginal revenue will be Then substitute 5 in place of Q everywhere in your expression. All right. Marginal revenue when Q equals 5 units will then be this 5 squared plus 750 times 5, right? And then divided by 5 plus 50 all squared. And you put everything into your calculator and get your answer for marginal revenue when Q is 5 units. Okay, so let's look at an example of the cost function now, finding marginal cost and average cost. So it just follows in the same way, except for that we will be using a cost function. So given that the total cost function for a product is given by 6Q squared divided by Q plus 2 plus 6,000, right? We are asked to find the marginal cost and the average cost for this product. So our marginal cost will be, marginal cost is derivative of total cost over with respect to quantity, dC dQ, which in this case, we can see that our C is made up of two terms, this term and this term. This term is a quotient, and this term is a constant, all right? So we apply the quotient rule on this term and apply the constant rule on this term to differentiate it. So on this term, this is my U and this is my V, basically. So it's keep V the same, differentiate U, we get a 12Q minus keep U the same, differentiate V, we get a 1 over the square of V, Q plus 2 all squared, plus derivative of 6,000 is a constant, so its derivative will be 0, right? And that's my marginal cost, basically. As I said, you don't necessarily need to simplify it further than this, okay? And our average cost will then be total cost over quantity, which was 6Q squared divided by Q plus 2 plus 6,000, okay? So all of this over Q over Q. So the final thing will be 6Q squared over Q times Q plus 2 plus 6,000 over Q, right? And that's our average cost. And similarly, if you were to find the marginal or average cost when Q is equal to maybe 2 units, for instance, all right, just like we did with the previous one, all you need to do is to substitute. So marginal cost at Q equals 2 will be just to substitute 2 in place of Q everywhere in the marginal cost function, all right? In the marginal cost function, you substitute 2 there and get your marginal cost for 2 units. Okay, so it's 2 plus 2 all squared, okay? And so on and so forth. Okay, then let's take an example on the consumption functions now. So, given that the income, so that's number 66 in the book, the consumption function for the US is in a certain year is given by C equals 6 plus 3I over 4 minus square root of I over 3, right? Where I equals 25, find the marginal propensity to consume and to save. Find the marginal propensity to consume and to save. Remember that I is the income. So marginal propensity to consume, marginal propensity to consume given by the C, the I is, we differentiate term by term, all right? So derivative of C, 6 is 0, plus derivative of 3I over 4. Okay, as I said, regard this, see this as 3 over 4, see this as 3 over 4I. Okay, if you see it as 3 over 4I, then by the constant product rule, keep your 3 over 4 the same, differentiate I, we get 1, minus this one, see this also as 1 over 3 root I, all right? So it will mean keep 1 over 3 aside, differentiate root I, okay? Remember that root I is I to the half, all right? So its derivative becomes a half I to the negative half. And that's our dc di there. Then all we need to do now is to substitute I equals 25 to get the exact value of the marginal propensity to consume when the income is 25. Okay, income is 25 Rand or $25. Okay, so our dc di when I is 25 will be 3 over 4 minus 1 over minus, okay, because this negative here, okay, it's a positive, it's a times, minus 1 over 6, 3 times 2 is 6, times 25 to the negative half. We are substituting I equals 25 in this expression to get our exact value for the marginal propensity to consume when the income is 25 units of money. Okay, so you then put everything into your calculator and get an answer. So this will be 1 over 5. So it's 3 over 4 minus 1 over 6 times 1 over 5, which is 3 over 4 minus 1 over 30. Okay, put that into your calculator and get the value for the marginal propensity to consume. All right, so then the marginal propensity to, so it's 3 over 4 minus 1 over 30. So we put the 2 on common denominator. So your marginal, so that's our dc di. You can use your calculator to calculate that. So our ds di, marginal propensity to save, will then be 1 minus this value. All right, 1 minus the value you get here will then be your ds di when I equals 25. Then let's take another example. Given that the marginal propensity to consume and to save, suppose that the savings function for the country is given by this, okay, the consumption function, okay, so this is number 69, given that C, the consumption function for a country, is 9 root I minus 0.8 root I cubed minus 0.3 I over square root of I. Okay, you are asked to find the marginal propensity to consume and to save. All right, when I is 100, when I is 100. Okay, so dc di will be, this is still a quotient function, which we can differentiate using the quotient rule. All right, this is also still a quotient function. So this is my u numerator and my v in the denominator. So keep v the same. So we already recall that I, square root of I is I to the half, right? So that when we differentiate it, note that we write it like this first. Keep this one the same. Differentiate this one, we differentiate term by term. So the first term, 9 stays aside, differentiate root I, we get a half I to the minus a half minus 0.8 stays aside, differentiate I root I cubed. Remember, root I cubed is I to the 3 over 2, right? It's exponential form. So its derivative will be 3 over 2 I to the half by the power rule minus 0.3, okay? Because 0.3 I, its derivative is just 0.3. So that's my V U prime minus, right? Keep U the same, 0.8 cube root of I, root I cubed minus 0.3 I. Differentiate V, we get a half I to the minus a half, all divided by V squared, right? The square of square root is just I. And that's our dCdI, okay? So when I equals 100, all we need to do, dCdI for I equals 100, is just going to be substituting 100 everywhere we see I in that formula for dCdI. 100 to the minus half minus 0.8 times 3 over 2 times 100 to the half minus 0.3 minus 9 times 100 to the half minus 0.8 times 100 cubed, okay, minus 0.3 times 100, all of that times a half, 100 to the minus a half, okay, all divided by 100, okay. Put all of this into your calculator and get your value for dC dI, right? And your ds dI will just be 1 minus the value you get for dC dI, and you get that value there. Okay, so that's that about the applications. Just know that marginal functions are just derivatives of the original functions, all right? Marginal propensity to consume, marginal revenue, marginal cost, and so on.